All right, let's get started with our multiple response experiment example, and we're going to use Taguchi methods to get this done. Now the file for this is multiresponse.taguchi.mpj, a Minitab project, which is what I have open that you can see right now. So this is a 6-factor experiment, factors A through F, and we have 3 variables as outputs. Okay, variable number 1 is something that we want to minimize. We have 3 data points per run for it. Variable number 2 is a continuous variable that we want to maximize. It has 3 data points per run. And then the last one is an attribute which has been coded so that we can treat these as a continuous variable even though it's discrete, but we want to minimize the value of the code. All right, so that's the objectives that we have. And let's see if we can actually create this design within Minitab so you can see how to do that. So stat, DOE, Taguchi, and we want to create a Taguchi design. All right, so we have a 2-level design, and we want to select 6 factors. The designs that are available to us would be the L8, which is what we've created here, an 8-run experiment that has up to 6 factors in it. We'll say OK to that. From a factor standpoint, we have factor names A, B, C, D, E, and F. And if we want to put in the levels, all right, let's just do this here. We'll type in low, take caps off there, low, and then a space and high. And we're going to have low, space, high. And I'm using the tab to scroll through this. All right, so we've got those. And then in the options, what you would do is store the design in a worksheet. So we'll say OK to that, and then we'll generate our design. So here's the design that we just generated. You can see here's the level settings. Usually in the first column in Taguchi layouts, we have the opportunity to hold a factor at the low setting for the first half of the experiment and then move to the second setting for the second half of the experiment. So if we have factors that are difficult to change, we can always place those into column A in a Taguchi layout. And then you would add the columns for your output characteristics that you're going to be measuring, and we would just type those in. So let's go back to the multi-response Taguchi Minitab project that we've opened up. We open the big blue eye. I'm going to go left over here to the Show Worksheets folder. I'm going to double click on Taguchi method 8-run DOE, which was the name that I've given that worksheet. And I'll make it a little bit bigger. And you can see that here's all of our data. So let's go ahead and begin to do our analysis. And when we use Taguchi methods, we have the opportunity to use the signal-to-noise performance metrics. So let's get started with this. So stat, DOE, and we're going to be doing it Taguchi, and we want to analyze the Taguchi design. And what we're going to do here is we are going to select variable 1, 2, and 3. So I'm going to hold down the Shift key. Variable 1, data points 1, 2, and 3. I'm going to select that. All right, graphs, signal-to-noise ratios and means. I can generate the plots. Now, I don't really need to generate any plots right now, so I'm going to turn those off because this is still the initial run of the analysis, and I'm not going to be making any decisions based on the graphs initially because we still have to go through the pooling. All right, from an analysis standpoint, all right, and we want the signal-to-noise ratios and the means. I'll say OK to that. We've checked all those. From a term standpoint, we want A through F in our model. All right, no combined effects. Analysis graphs. All right, and here's where we could look at the residuals, and we really don't need to do that because we're doing design experiments. We're just going to say we don't need that. We're going to say okay, we're not going to select any of that. From an option standpoint, we're going to use nominal is best, all right, which is going to be minus 10 times the log of the standard deviation squared. And what this is going to do is going to calculate this performance metric for each experimental run. And then what we'll be able to do with that when we do our analysis of variance, it's going to help us to identify the variables that influence the variation about the average value. So we're going to have a mean analysis, which is going to allow us to move and adjust our distribution, okay, because that's going to look at the centering of the process. And then this nominal is best signal to noise metric, this performance metric is going to help us to identify the factors that influence the variability. All right, so we may have some factors that influence the mean and variation, or just one of those two. And this will help us to understand that. So let's go ahead and say okay. And we'll scroll back up here. And let's start with the analysis of variance for the signal to noise ratios. Now, the first thing we want to look at is our F statistics. And the rule in pooling is we want to pool into the unexplained term all F statistics that have a value of 1 or less. So we can see that factor B is at 0. Factor D is 0.74. So those immediately need to be pooled into the unexplained term. The next rule is if, after taking care of the F statistics, we will pool the next smallest F statistics until we have about half of the variables remaining that we started with. All right, so we started with 6 variables, so we should finish with about 3. All right, well, 1.79 and 1.66 are about the same size, so both of those are going to get pooled. So the only thing we're going to keep in this is factor A and factor C, okay, from an analysis of the signal to noise metric. Now, if we scroll down here to our analysis of variance for the means, notice now that factor A does not influence the mean. It did influence variability. We have factors B and C and D, and then we have the other 2 variables, E and F, along with A, that all have F statistics that are equal to 1 or less. So we're going to pull those 3, and we'll keep B, C, and D in our model. So what we need to do now is rerun our analysis. So we're going to come up to the Edit the Last dialog box, and still the same variables, but now we go to our analysis. We want our signal to noise. We go to our graphs. We now want the signal to noise and the means graphs. The terms, we want to keep A and C. Okay, so we want to keep A and C. All right, and that is for the signal to noise. So hang on a second here. Let's go back to our analysis. All right, we just want to display the response table for the signal to noise. All right, analysis graphs, we're not going to do any of those. The options that we have, nominal is best, that's not going to change. And we're going to go ahead and do this for the signal to noise. Now we're going to have to come back and do it again for the means, but we'll do that in a second here. So let's do the signal to noise. And we have our final analysis, and we'll look at all this in a second here. Let's go back to our Edit Last dialog box, and now for the graphs, we want to have, we want signal to noise and the means. We want the means. And from a analysis standpoint, we want the means now. I'm going to turn off those. And from the terms, let's take all of these out, and we want to put B, C, and D in here. So we want B, C, and D. or from our graphs. We just want to have the means. Okay. So now we can go ahead and say OK. And now we have our B, C, and D for analysis. So let's take a look at our session window. So go up to Big Blue Eye, go right to the session window. And let's scroll up. There's analysis of variance for the means. We have our analysis of variance, okay, for our, okay, here we go. Here's the analysis of variance. We can see that factor A, 1 minus P, so that's a 99.8% confidence. And factor C is at 0.06, so that's about a 94%. And we got about an 84% R squared, so that's all good. Okay, so we have our analysis of variance here. If we take a look at the means analysis of variance, okay, so we've got our coefficients for the regression model. Here's the analysis of variance, and we can see that we've got a 99%er, another 99, and a 95%er. So B, C, and D are all significant. We can now take a look at the graph. So the Big Blue Eye, go over to the graphs folder, and let's start with the effects plot for signal to noise. And in signal to noise, what we're trying to do here is it's bigger is better on a scale that goes from minus infinity to positive infinity. So we're going the positive direction. So the best setting for factor A is going to be 2, and the best setting for factor C is going to be 1. Okay, so the low setting for C and the high setting for A. And if we come over here to our graph folder once again, and we'll look at the means, we're trying to minimize the average value. So factor B needs to be at the second level. Factor C is at the first level, so there's no conflict there between average and reducing variability. And then factor D is going to be at the second level. All right, so we found out that factor C not only influences reducing variability, but also the centering. And we know that factor A influences reducing variability, does not influence centering, and factor B, C, and D all influence the centering of the process. So by using the signal to noise performance metric, we found a factor that only influences variability. And then we've also found the factors that influence the average value, and we found out one factor, C, influences both the mean and reducing variation. All right, so that's the power of having the multiple data points per experiment run and using the performance metrics when we do our analysis. All right, so let's go ahead and see if we can quickly bang through variable number 2. And so what we're going to do is we're going to come up here to editing the last dialog box. We're going to delete out, okay, that performance output characteristic, and now we're going to use the shift key. We're going to highlight variable 2, 1, 2, and 3. All right, from the graphs standpoint, we don't need any of those right now. From an analysis standpoint, let me just turn those off. We want to have the signal to noise ratios for, and also for the means, the terms that are going to be in the model. Let's get rid of all of them, and then we'll put A through F back in, A, B, C, D, E, and F. Those are all in the model now, because we're starting all over again. All right, options, we want to have nominal is best. So we're going to get a means analysis and looking at the variability. Let's go ahead and say OK. And I'm just going to make this guy big so it fits in our window here so we can see it. There we go. Now let me scroll up. All right, so here's our analysis of variance. And we can see in this one, our R-squared adjust is only 26%, so we don't have a real strong model here, that's for sure. So this is variable number 2, and if we look at the smallest F statistics, we can see that D immediately needs to get pooled because it's less than or equal to 1. And for Sn, we're going to keep factors A and B and E. All right. And if I come down here and look at the analysis of variance for the means, we are going to be keeping factors A and B and E. And we're going to be pooling C, D, and E. So let's go ahead and run our analysis. Now in this one, we've got the same 3 factors for each A, B, and E, so it's going to make it a little bit easier. So let's go back here to our model. Okay, from analysis, we want the response tables, all right, the terms, all right, we want A, B, and we want to have E. All right, so A, B, and E, we want to have those 3 factors. And, okay, we're not going to do any of those. Options, nominal is best. All right, make sure double check our graphs, signal to noise, and the means. Okay. And go ahead and say OK. Go back up to our session window. And here we have our ANOVA for the means, and then we have our analysis of variance for the signal to noise. So you can see that we really don't have significant p-values here for A, B, and E, even after pooling. We'd like to see these p-values to be 0.05 or less. And then if we come over here, we only have really one significant factor, factor E. And one of the things that we want to use when we do our looking at the multiple responses, we're going to bear in mind the p-values and also the R-square adjusted to help us understand how significant the analysis is. So this analysis is not really very significant for variable number 2 for signal to noise, and it's really only significant for E as far as the means are concerned. So let's take a look at the graphs real quick. Go up to Big Blue Eye, go over to the Show Graphs folder. Let's take a look at the plot for the means. And we have A, B, and E. And in this case, we're trying to maximize. So we want to be at A, level 2, B, level 1, and E, level 1. Signal to noise, which is really not very significant, we want to be bigger is better. So A at the second level, B at the first level, and E at the second level. All right, so there's a conflict there, but we know from our analysis, go back to the session window, we know that E for the means is a very strong factor. So it's going to win as far as where we should be from a means analysis. All right, so let's take a look at the last one, which is the attribute. So delete that. I'm going to highlight ATT 1, 2, and 3, select those. Graphs, we're going to turn those off to get started with. The analysis, we're going to not display those right now. We're going to fit the model for signal to noise and means. All right, terms, take them all out, and we'll put A, B, C, D, E, and F back in. All right, options, we want to use nominal as best, and say OK. All right, so I'm going to scroll up again to our SN analysis, and we can see from this that we want to pool the smallest F statistics. So there's 3 we're going to keep and 3 we're going to get rid of. So we are going to keep from the signal to noise, we're going to keep B and C and E, and the smallest ones of F and D and A, those are going to get pooled. And if we come down here and look at the means analysis, we want to keep C, and we want to keep E, and we want to keep F. and factor A less than 1, factor B, and factor D are all going to get pooled. So from the signal to noise, we keep B, C, and E, and for the attributes, it's going to be C, E, and F. So let's go ahead and do our final analysis. All right, let's start with our signal to noise, and fit the linear model for the signal to noise, display responses for signal to noise. The terms that we're going to keep are B, C, and E. So we're going to take A, we're going to take out D, and we're going to take out F. So we have B, C, and E. And we're going to go ahead and say OK. All right, so we've got B, C, and E. And if we look at this real quick, we can see that we want to be at B level 1, we want to be at C level 2, and E level 1. All right, and we'll run this again. We'll take a look at our, okay, now for the means. Yeah, we want the means. So you can see you got to do a little bit of clicking in here to do this. And we want C, E, and F. So we're going to take B out of this, and we're going to put F back in. So we got C, E, F. And this is for the average value, looking at the means. All right, analysis graphs, options, and we're not going to actually be calculating that. The graphs, we're going to print out the means and say OK. All right, so we have C, E, and F. Now we're trying to minimize this, so we want to be at C2, E1, and F1. All right, now let's take a look at the session window real quick, and we'll take a look at our analysis of variance. Okay, so the ANOVA for the signal to noise, we can see about 61% R squared, and factors B and C are a little bit, they're in the 90% range. All right, they're not quite 95%ers, but you know, that's fairly significant. There's only 3 data points per run. It's not like we have a great large data set. And then if we come over here to our means analysis, we can see that it's about an 84% R squared, which is a little stronger model. And we have some stronger factors here, C and E, 1 minus 0.016. So we're, you know, in that 99% range, and then this is about a 93%er here at F. So we'll take all of this information, the p-values and the R-square adjusted values, when we go to build our table that we're going to use to evaluate what should be the best settings based on the fact that we ran 1 experiment. We've got 3 output characteristics. If we have any conflicts, we want to look at the strength of the analysis and the p-values, which will help us to understand what are going to be the best overall settings, so that even though we ran the 1 experiment, we're going to optimize it for our continuous variable number 1 that we're trying to minimize, our continuous variable number 2 that we're trying to maximize, and the attribute characteristic that we're trying to minimize. So that'll do it for what we can do in Minitab. Now we need to take some of this information, put it into that spreadsheet table that you have in your toolkit, and then you'll be able to do the comparison to pick the best level settings based on what you've learned from the strength of the analysis, the p-values. So there you have it.